discussing about the InstructGPT paper. So this is done by the OpenAI team, and in this paper what they have basically done is research a way to train language models to follow instructions with human feedback. So first we look at their motivation behind this research. So what they wanted to do was align language models to user intent. So what do you mean by aligning is that if you take a language model and take its output, it should achieve three main goals. So the first one is it should be helpful to the user, and then it should be honest. It should give accurate information, and in the cases where it does not know the exact response, it should say that I don't know instead of hallucinating the wrong answer. And also it should be harmless. It should not cause any physical or psychological damage to the user or the environment. So in cases where a language model fails to achieve these three goals, we say a misalignment happens. So when the training objective does not capture those goals, misalignment happens. So now let's look at the prior works that where people have been researching on to do these things like aligning a language model to these three goals. So first, so in this InstructGPT paper, what they have mainly used is this RLHF, reinforcement learning from human feedback. So this have been used previously for various other tasks. So it was originally devised for training like simple robots in simulated environments. And other than that, RLHF has been used for tasks like summarization and also domains in domains like dialogue, translation, and story generation likewise. And also there have been cases where people had tried to utilize written human feedback to augment prompts and enhance the performance of the GPT-3 model. So what the InstructGPT paper does is they extend this RLHF to align model across like a broad NLP task. So most of these cases they are specified on a single task. So in InstructGPT they try to generalize it to all of these tasks. And yes, and also I mentioned about harm, the one of the three main goals. So people have tried to mitigate these harms that is caused by language models. So there have been instances where people have used filtering and blocking certain words and use certain safety specific control tokens, and also word embedding regularization and data augmentation to achieve this harmless goal of a language model. So as you can see, none of these methods have used human feedback to train a model and actually align a model to a user. So that's what's special about this InstructGPT. So now let's look at how what is InstructGPT's approach to achieving these goals and aligning the model. So as I said, so they use human feedback. So to do that, so they first need human annotators. So they hire 40 annotators from Upwork and Scale AI companies. So they are tested in a screening test, and the researchers measure the performance of all of these annotators and pick out them. So they look if the annotators are sensitive to preferences of different demographic groups. So they should be coming from like diverse groups, and also they should be good at identifying harmful outputs. So these two are the main things that the researchers have been looking for in the annotators. So and again, so this is so these annotators are for the training part, and then they hire a separate annotators for the evaluation. So they would not go through that screening test, and they are just hired from the same company, but they are not performing anything in the training part. So they are unbiased and they are new to this model. So yes, so in the InstructGPT you can identify main 3 steps. So in the first step, what they do is collect data for training. So for this, like they collect a prompt dataset. So that is done by prompts submitted to the OpenAI GPT-3 playground. And so like initially, before introducing InstructGPT, there have not been like any prompts that are instruction following kind. So they have hired these annotators to generate prompts that are more instruction like. So that's why they use annotators here also to write the prompts. And from these prompts, so they filter out the personal information of the users and also remove duplicates and also limit 200 examples per user as well. So then from the data set that we collect from here, we get a prompt from that data set. So this is like the so these are some example prompts that we get. As you can see, this is the prompt distribution from the OpenAI GPT-3 playground. So you can see most of the percentage is for generation, open question answering and brainstorming, and very little are for like summarization and classification. So I will be explaining in the future slides as well. So because that there are like a very small percentage on the summarization and classification tasks, like those are the NLP tasks that people have like really worked on. So because of that, this model does not perform very well in like existing NLP datasets, because you have like a very little percentage of this. So yes, so once a prompt is sampled from the prompt dataset, they pass it to the labeler or the annotator. So he will be writing down the expected output from the prompt.
So who wrote the prompts in the GPT-3 playground?
So
regular people, right?
Yes. So then that those prompts and the expected output written by the labelers are used to train the existing GPT-3 model. So this GPT-3 is 175 billion parameters. So they train this existing GPT-3 and we call this SFT. So in the annotations throughout the paper, this is referred as SFT. So yes, so this model is trained for 16 epochs and they use cosine learning rate decay and a residual dropout of 0.2. So now we have a fine-tuned GPT-3 model. So now we will be moving on. Yes, in the equations, in the upcoming equations, you can see this fine-tuned SFT as pi SFT. So after this, now we have the trained fine-tuned model. We move on to the second step. So in the second step, what we do is we train a reward model. So what happens in here is that based on the prompts and the responses, the labelers give like a reward to each of these response and then train the response model, a reward model. So I will go through it. So yes, so we take a prompt, pass it to the language model, and then we get like several responses out of it. So yes, out of that responses, we tell the labeler to rank each of them from best to worst. So this is the example case. So the labeler has ranked these 4 responses like this. So yes, so and also in the paper they have mentioned that each user is given 4 to 9 responses per prompt to like rank. And then what they do is they pass this data to this reward model and then train it. So actually this reward model is the same as the SFT here. Same as the SFT here, but the last layer removed. It was mentioned in the paper. So yes. So in the reward model they use this loss function. So before understanding the loss function, let's look at the these notations. So this R theta is the reward model that we are trying to optimize, and X is the prompt, and YW is the better completion, YL is the worst completion. So to understand this loss function, let's like first forget this part. Just forget this part. Just assume it's like a normalization part. So if you look at this, so what they do is they pass the prompt to this reward model and get a scalar value. So that's what we get here. And so here this is the prompt. Yes, alright. We pass the prompt to the reward model and get the scalar value. And like as I mentioned, so for each prompt we get different responses, right? Like assume this is 4, and so what labelers does is they choose pairs out of these responses and identify which response is better than the other. So if we have like 4 responses, there will be 6 pairs, like 4C2, so 6 pairs. So they divide. So they just subtract the reward on better completion and also the reward on worst completion and get the logos of it. And if we look at now, I'll be discussing about this part. So this part is added because like if we take like, so we get 4 responses out of it, we get 6 pairs. So if we pass all those 6 pairs to this model and we update the gradients, so we will be updating like 5 times for each prompt. So this is a very computationally expensive, and also it leads to overfitting as well. So what they do is they batch like a prompt. So what they do is, so all the 6 prompts are considered as a whole batch, and then they calculate these logbots and take the average out of it. So that's what is this part. So this is basically done to remove this overfitting problem. And yes, so now we have the trained reward model. So now we will be moving on to the third step, the final step. So this is where they optimize the policy that was trained here using against the reward modeling using reinforcement learning. So what happens here is we take a new prompt from the prompt dataset, pass it to the policy that we fine-tuned earlier, we get a response, pass it to the reward model and get a reward, and then pass it to this policy and update this PPO. So here this is where the RLHF is comes into play. So yes, so in this step they have identified like 2 problems. So like as you can see from this reward, this policy gets updated. So what happens in this model is they try to give out a response that maximize the reward that we get from the reward model. So when the policy is trained, maybe like if we are only using like, forget about this part, if we are only using try to maximize this part, the reward, so he will be this model will be prompted to like generate like out of the blue responses to get a higher reward. So to mitigate that, they introduce this part. So this is where they add like a KL penalty that makes sure that the policy model output does not deviate too far from the SFT that we trained earlier. So yes, and as you can see, this beta is the one that gives the weightage to this penalty. And yes, another problem that they have identified is that just using reinforcement learning, it degrades the performance on many NLP tasks. So what happens here is that so because of so what they tried, that they have not like specifically mentioned like how they are doing this, but they have mentioned this equation. So they have mentioned in the paper that so doing by adding this part, they are mixing the pre-training gradients into the PPO updates, and what they basically does is like maximize the likelihood of the pre-training datasets while training this policy. So this gamma value is the weight given to this penalty. So without that gamma, we call this model the PPO, and with the gamma part, we call this the PPO PTX model. Yes, so this is the overall method. So if I summarize it, so first we have the SFT, the GPT-3 fine-tuned on the human demonstrations, and then we have the reward model. So this is used to train the PPO and the PPO PTX models, and then we have the PPO. PPO is the technique that is used for reinforcement learning. So this is proximal policy optimization. So using this method, we further fine-tune the SFT model that we fine-tune here. So and yes, then we have the PPO PTX, where they at that mix the gradients of the pre-trained datasets. So yes. So now let's look at the evaluation part. So in the evaluation, what they have basically done is test whether the model has achieved that three H's, the main three goals. So to identify if it has been helpful, so they pass the responses to like those annotators that are hired only for evaluation, and check if it is preferred rather than output from other models. And then the honesty, so to check the honesty, they check whether it hallucinates, and also they use the truthful QA dataset to measure the honesty. And then for measuring the harmless, so they use these two datasets, real toxicity prompts and Wigner gender and cross-hairs dataset. So now let's look at each of these. So before going into that part, so first we look at the prompt distribution. So this is an example cases of API distribution. So as you can see, these are the prompts submitted to the GPT-3. So these are not very instruction-like. So, and then again we have some prompts that are submitted to the InstructGPT model before this paper. So this paper is based on the text DaVinci 002. So before that they have other models as well. So these are more instruction-like. So these are the prompts distribution, and also they test on these NLP tasks as well. So in the paper they have mentioned that they are not performing very well to these public NLP tasks because of that dataset issue that I mentioned earlier. So now let's look at this helpfulness. So yes, so what they have basically done is they have like tested on the GPT distribution and also the instruct distribution separately. So In here they have the held out workers. Those are the separate annotators that they have hired only for evaluation, and also the training workers, so they have tested on them as well. And yeah, and then they also tested. They have tested the preferences of the labels using all these models. So this GPT prompted is the one where they prompt the GPT to be more instruction-like, they just add a prefix to the prompt and make it more instruction-like, and then you get the model. And yes, as you can see from these results, so the yellow and the red color ones are the PPO and the PPO PTX, so they are performing very well in the GPT distribution and as well as the instruct distribution. And also another thing to notice is that the preferences of the training workers and the held out workers are somewhat similar. So this proves the fact that this RLHF generalizes to all of the users. So yes, and this is the test where they hallucinations. So as you can see from this graph, the SFT, PPO and the PPO PTX are generating very less amount of hallucinations compared to the GPT and the GPT prompted. And also, they have not mentioned this in the paper, but I have noticed that SFT is performing very well in case of hallucinations. They has the lowest amount of hallucinations. I'm not sure of the reason behind this, but it's something interesting that we can know. And yes, so this is where they have tested these hallucinations with various model sizes. So they have tested this 1.3 billion parameters, 6 billion parameters and 175 billion parameters. So 175 billion is the parameter size of GPT-3 and 1.3 billion is the parameter size of InstructGPT. As you can see here, in the same model size, InstructGPT is performing very well in the case of hallucinations. And yes, so they have tested their models with fine-tuned models. So this is like the GPT and GPT prompted, you met them earlier, and these two are where this plan model means they just fine-tune the GPT-3 model using the FLAN dataset, and also fine-tune the GPT-3 model using the T0 dataset, and then pass it to the labelers, and they have asked the preference of the labelers, and you can see again the PPO, PTX and the SFT is performing very well compared to all of this. And in the paper they have mentioned why this is not performing very well. So basically, I explained it earlier as well, because of the issue that in the prompt that is used to train the InstructGPT, they have very less amount of summarization and classification tasks. So in the FLAN and the T0 datasets, they are more generalized on these public general NLP tasks. So the API prompts are more often used for open-ended generation and also brainstorming. So yes, that's the reason behind it. And they have measured the truthfulness of the models as well. So the grey bar is the truthfulness and the colored bar is the truthfulness with the informativeness of the responses. Again, you can see the PPO and the PPO PTX is performing very well compared to GPT. And again, to measure out the truthfulness, they use this instruction, they use this question prompt with the instruction. So what they basically does it that in the instruction prompt they say not to to say that I have no comment in cases where it is not sure of the correct answer. So you can see here, interpret each question literally and ask a question about the real world. And this is, and reply I have no comment unless you are completely certain of the answer. So they have tested on this as well. So again you can see with the instruction and plus the question prompt, the PPO, PTX and the SFT models are performing very well. So these models are these models like choose truthfulness, being truthful and uninformative against being like generating something false. And again the hallucinations can be used as a measure about the truthfulness as well. So in cases where like on closed domain tasks they generate very less amount of hallucinations. I explained that earlier as well. And then to test on the toxic behavior and the biased behavior, they have used these kind of prompts. So you have the basic prompt, and then they use prompts where you say like be toxic or not to be toxic. And yes, on that test results you can see if we tell the model to be respectful, the SFT and the PPO PTX generates less amount of toxic responses. And if we even if we don't say anything, the performance is bit similar, but in the SFT they does not they generate less amount of toxic responses. So and again if you say the model to be rude, it will be rude. So it will generate more toxic responses than GPT-3. And to test out on the bias, they have used these data sets. So in the paper they have mentioned that they don't have much of an improvement in this bias case. So it is very similar to the performance of the GPT-3 model. And they have given some qualitative examples as well. So in here the prompts are 96% English. So this is a case where they give the prompt in some other language. So they say that the InstructGPT is not trained on this language, but they generate a more a very good response compared to the GPT-3. So this proves that using that alignment methods, so the model generalizes to producing what the user is intending. So yes, so this is an example, and this is another example. So where they give a code to the prompt. So in the prompt they say to explain the purpose of the list C. So the GPT-3 model generates a very uninformative responses, but the InstructGPT gives a very explained response. And also they have mentioned about some mistakes that the InstructGPT model makes. So it incorrectly assumes the premise is true when it is not. So an example case is they ask the prompt why is it important to eat socks after meditating. So this is rubbish. So the GPT-3 also mentioned something, but what the InstructGPT does it assumes that we should eat socks after meditating, and gives a full explanation on that. So yeah, so that's one of the mistakes. And then again it has the issue of overly hedging. So overly hedging means if you give a prompt, what happens if you fire a cannonball directly at a pumpkin at high speed. So you know that the pumpkin would explode. What the InstructGPT says it goes through all the factors. So he says that we have to consider the size, weight and density of the cannonball, and also what the pumpkin is made of, the velocity, impact force, and explain on everything, and then finally say likely possible outcomes include breaking or knocking the pumpkin to the ground. So that's one of mistakes. And again, so they have mentioned, like if in the prompt we give like too many constraints, InstructGPT won't perform very well. And if we move on to the discussion part, so they have mentioned about the alignment of the model and also some of the limitations as well. And you can see here, like they have mentioned that increasing investments on alignment of existing language models are more cost effective than training a larger model. So to prove that fact, they have mentioned the results that they have gotten from the labelers. So they say that the 1.3 billion parametered InstructGPT model are more preferred than the GPT-3 model, which has 175 billion parameters. And also, like what I mentioned before, like it generalizes following instructions to settings that they have not supervised the model in, like in the case where they generate responses to unseen, like unknown languages. And also about the alignment, so they have mentioned some issues there. So what they, for aligning the model to user intent, they use those 40 annotators. So the issue with that is most of them are English speaking, like 96%, and also they live like in a specific area like United States or Southeast Asia that works in this company. So like they are very well paid and they are like willingly doing this work. So there's that issue as well. And also there's another issue that they are addressing, like that they are telling, like they are not sure what they are aligning the model to. So maybe the labelers or maybe the researchers. So why they mention this is that the researchers are the one who give the instructions to the labelers to use as a guide when generating the prompts and also writing out the responses. So you have an interference of the researchers in this case. So because of that, the model can be biased onto the researchers and also the mentality of the labelers as well. So yes, they have mentioned that more studies needed to on the exact effect of different instruction sets and different labelers. And yes, and also in the training data, they have prompts that are submitted to the OpenAI API. So most of these prompts are like what customers think is valuable and also what their end user is thinking is valuable. So in some cases, this might not agree, the customer won't agree with the end user. So like the customer might try to for example case, the customer might try to maximize the screening time of a user, but it is not thought as valuable to the end user. So there's that issue as well. And also so they have mentioned that OpenAI customers are not representative of all the population. So in the end, they mentioned that the goal of the paper is to demonstrate that this alignment technique can align to a specific human reference group for a specific application. So that's what important here. And also they have given some limitations as well. So as I explained earlier, the toxic or biased behavior is not that much improved. And also the alignment process should be more fair and transparent. And yes, so those are some limitations. And to summarize the whole thing. So the when we look at the performance, and like the labelers more prefer the InstructGPT than the GPT-3, and regarding the truthfulness as well and the toxicity, the InstructGPT is performing well, but not in the case of biasness. And so for the findings, we can identify that those RLHF is like what is important to align a model to the user's intent. So yes, so that's about it. So for the implementation part, so like in order to like fine tune this InstructGPT model, so we need a API key that we have to pay for. So yes, I'll just go through some blogs that they have mentioned about fine tuning this. So yeah, so we can use the OpenAI playground to fine tune the models as well. So just we have to submit the data set. So you can see here. So this is what we get in the OpenAI playground. We just have to submit the data set and select the model that we need, and then just give the validation data as well if you need, and then just do the fine tuning. So for this also we have to have a paid account. So in that case, I was not able to do this, like test this out. And also we can do it with Python as well. It's simply this is where they load the data set, and this is the data set generating part. So this is where they give the OpenAI key and then get the model, and then just pass the data to the model and just get the fine-tuned model and test on it. So that's about the paper.
Questions or comments? Does anyone know anything about what happened after the InstructGPT paper? How does actually ChatGPT-4 works and so on? Using the pre-trained model again and again for different aspects in the same system is seen here, right? So that must be definitely there in the data systems also. And of course, multimodality is there in new systems, right? How do these systems work for something like Python code generation?
They have something called parallel programming. So what they're doing is like they're giving the Python code and the instructions they are giving us comments. So that's what they're doing. Also, one question I have is like, GPT 3.5, 4, all of these are like still the base model is the transformer. Right? So, like, since they are stacking up many layers one on top of the other, their capability is good. Right?
Yes.
So, basically, these are still good next wave generators. Right? That's what they are.
Yes.
So, because of the large number of parameters and these fancy pre-training methods, they are performing well.
Yes.
But still, on some tasks, it's performing extremely badly. And obviously, these do not have the thinking capability.
Yes.
So, in the vision field, we have like Professor Anderson has suggested of something like a world model, where it takes in from the perception module, it takes in what it extracts features, and then it has other parts also which does the thinking part. So why do and also we know in vision we cannot extract everything which we want, but in language we can extract these transform models have performed extremely well at extracting the features. So why not go into something like a world model concept where using something like a transform encoder, we extract the features, understand the thing, in BERT what they showed is we using a bidirectional model we can get the full understanding of the input, and then why not pass it to some other modules where they do the thinking and then pass it to the decoder part. Because these models are performing well because of the large parameter count.
Yes, absolutely.
So maybe we can achieve the same performance with smaller models with that architecture.
Yes. Careful architectural changes are very powerful. But the thing is, since you do not know about the newer models, they may have benefited already from these possibilities. Anyway, about the world model, what bothers me is, if you take language, that is second-hand knowledge, that means a human being interpreted that and wrote it on the internet or something about, let's say, Pearl Harbor attack. It may not be the actual thing that happened, but it's the interpretation of a human being, and that the language model learned. So it's not first-hand information. First-hand information comes by observing the events and testing the environment. That's what you are trying to do, right? A true perception model, in addition to the thinking. It will happen, and I think it's very exciting to work in this area. But computational power, you have to go to a place where computational power is available. Reinforcement learning with human feedback, supervised fine-tuning, these concepts work in other systems also, right? Those things we can learn from this paper. This PPO thing, does anyone know about that in detail? It's a reinforcement learning model, right? PPO. My understanding about reinforcement is very, very poor, so spend some time.
So I think there's a deep math part in it. I have learned, but I didn't understand because of the math part.
Yes. There's a certain lectures by Peter Beal or somebody.
I got it from that in Coursera they have a also GenAI that they are doing a good explanation.
So as far as the language models are concerned, it's a very confusing time to live in, right? so many things are happening too fast. Difficult to grasp. But that's why discussing with people is very important. Any other comments or questions? Shall we thank the presenter? Thank you.